name is Tanya Janka, and I wrote a book. Hi, Kellen. Welcome, everyone. So I wrote a book, and it is called Alice and Bob Learn Application Security. And what I have done is put questions at the end of each chapter to discuss with all of you. And I've been inviting guests on once per month and holding these live stream events so that more people can be welcome. So this week, or this month, I guess, I'm going to have my friend SheHacksPurple on from Reshift and from OWASP Ottawa. That's how we became besties. And then my friend Aaron Lord from Hello Secure. So Aaron's a bit late because basically his computer exploded on him, which is like obviously awful and we feel his pain. But this month, we're going to talk about secure coding. Okay, so let's bring on Sharif and introduce him.
Thanks, Tanya. Hi, Tanya. How are you? Hello, everybody.
I'm good. How are you?
I'm doing great. I'm doing great. It's great here in Ottawa, Canada. Lovely day, sunny. Yeah, cannot complain. And this is the second day after the lockdown, so we're allowed to get out of the house. So that's awesome.
Yeah. Seriously, I can't imagine what it's been like in Ontario because I live in British Columbia, but I used to live in the same city as Sharif. That's how we met.
Yeah. Even
But
the
now
side, like even when you were here, you were on Gatineau. Gatineau is way better than us. So at one point,
good for them, but
at one point, the premier, I don't know why somebody told him this is a great idea. He went on television and said, "We are imposing the strictest constraints in North America." I was like, "Why is that a good thing? Why are you?" That's not good, man. So, anyways. It's good for health, but I mean, a year after the pandemic or a year and a bit, I don't know if it's a good thing. Anyways.
Yeah, I agree. Sharif, can you tell everyone a little bit about you, and then I'm going to tell them a little bit about me, and then let's talk our favorite topic?
Yeah, that sounds great. Hi, everyone. My name is SheHacksPurple. I'm a software developer by training, by profession for about 6-7 years. 2006, 2007, something amazing happened to me where I got introduced to security. So I realized all of the insecure code I was writing at this point. I was writing a lot of Java, a lot of .NET. So I realized what I was doing, and I decided to repent. So I joined OWASP Ottawa, became the chapter leader, met a lot of amazing people. Obviously Tanya and Nancy and a lot of other amazing people through the OWASP journey and OWASP Ottawa in particular. Worked in a bunch of enterprises doing security code review and pen testing, and then I started my own consulting business where software secured, where we do penetration testing as a service. And then a few years ago, because I don't have enough and I have 2 kids and I have another company, I decided to open another company, to start another business. Don't ask me why, I'm just nuts like that. So the latest company is called Reshift Security. And Reshift Security is trying to bring security early in the software development lifecycle, particularly to developers, and help them write secure code from the get-go. So that's in a nutshell all about me.
Nice. Show off your shirt. He's got a Reshift shirt.
Reshift shirt here. Reshift shirt here.
Nice. Very nice. And for those who might not be aware or listening later, my name's Tanya Janka. I'm the author of the book Alice and Bob Learn Application Security that we're talking about today. I'm the founder of SheHacksPurple, basically a school for people to learn online about secure coding, application security, and way more stuff. And Sharif and I have been friends for years. This dude's awesome. He has mentored me a lot. So he was in security and we met because I invited him through a friend to come present at my office. So I was a lowly little dev then. And he introduced me to this whole world. And then our other friend, Nadim Duba, he was like, "Hey, you should come to this cool workshop I'm giving for this thing called OWASP." I'm like, "What's that?" And then I was hooked. And it's all over. I was like hanging around all the time, but Sharif was really good at tolerating me, just following him around.
Yeah, I mean, for everybody in the attendees, if you want to look at an example of somebody that saw like a passion and hung up to it and did everything that they can in their power to capitalize on this passion, that would be Tanya, right? There's a lot of people who want to come into AppSec or in security in general, but which is great. We need a lot of people in AppSec, in security in general, right? But it needs work. It needs work. It needs work. It is not. It's a kind of like a simple concept from the outside, but then it needs a lot of work to build them, because you're actually protecting the confidentiality, integrity, and availability of a big enterprise. So to be in that position, you need to work on yourself, and that Tanya did just that and more.
Thank you. Thank you.
Yep.
So obviously we like each other a lot. We say a lot of good things about each other to a lot of people.
Obviously we do, yeah.
Okay, so I want to talk about secure code, and I was kind of thinking so this is the chapter on secure code, and I was kind of thinking we could talk about some of the topics and then go through the questions at the back. And I know Aaron's on his way. He's just basically his computer just fell apart. He sends his apologies. This is not his fault. And also, if there are noises coming up on my mic, because every single one of my neighbors has decided to start a home renovation this morning, let me know and I will close the windows. But the first thing in my secure coding chapter, I talk about selecting your framework and your programming language. And like, I think this is pretty important. What do you think, Sharif?
Yeah, I mean, not all programming language and frameworks come equal from a security standpoint. In a lot of cases, security does not, unless you have pretty strict security requirements. In a lot of cases, the software developers, the architect dictates the tech stack, right? However, I can say in every single situation, you might have 2-3 options to work with. So for example, in Java, you have Spring and struts. In .NET, well, you don't have an option really. You're kind of stuck, but you get the point. In a lot of cases, you do have choices, even if you want to go JavaScript, even if you want to go Ruby. I don't know if so in that case, I invite you to look and evaluate security, to pick in the stack of choice, pick the best stack from a security standpoint. It's going to save you a lot of pain.
Yeah. So in the book, there's a story about Bob, and it's a story that happened to me, because Bob is me basically from like around 16 till around 30, and then Alice is me from around 30 to my 40s, like now. Gotcha. And I feel so like I was working somewhere and we did .NET, and we did this super old, weird, wild framework that I had never heard of before called Centura. Have you ever heard of that?
No.
Yeah, it's worse than garbage. And
is that in-house? Is that built in-house, or is that they bought from somewhere? Or
it was a thing they bought from somewhere, and so they were going to build a new project, and they really, really wanted, like, they basically, wait, you're Bob. I'm Bob and I'm Alice. I don't know. But basically, like, the new project, like the project leader was like, well, they need job security, so we're going to build the brand new app in Centura, a thing that was not supported anymore, that was 1 million years old. And I was like, oh no, we are not. That's not acceptable. And I convinced them to send a bunch of the Centura people on .NET training instead of intentionally creating technical debt. I'm like, what you're doing is investing in your employees. Your employees are going to be more awesome now. And so I've heard that, so it's been years since I've worked there. I've heard they've gotten rid of, like, upgraded or changed all the Centura projects now. And now all those people that used to do Centura all do .NET and, like, have more modern skills. And I'm like, yes, I hope I was some small part of that decision.
That was a great decision, if you ask me. But here's the thing. When people say, okay, let's stick to the old Swiss cheese framework or language. Let me ask you this. So you're buying yourself a couple of years worth of job security, but the cost of that opportunity, if you went and learned something like .NET, where there is a global need for a language like this, right? So, I mean, your department might close down. Whatever can happen, you cannot guarantee this, but you cannot. But something like .NET is not going away. So you might as well get on the new language.
Yeah, I totally agree with you. I remember someone saying to me once, "What if we train them and then they leave?" And I responded with, "What if you don't train them
And they stay.
and they stay?"
Yeah,
And the person gave me a frowny face.
yeah,
Yeah.
yeah. He will get it later. He'll get it later.
Yeah, they'll
He'll
get
get
it
it.
eventually.
Yeah, he'll get it later.
So, one of the other topics we cover in secure coding, and I don't know if this should be maybe now that I think of it, like right now in the architecture book or the architecture part of the book, or if this should be like the design part or in the secure coding part, but like HTTP verbs. So
Mm,
when I was a dev, I didn't think twice. I just used get, post, get, post, get,
mm-hmm,
post. That's it.
mm-hmm,
But it never occurred to me to disable all the other ones because bad
mm-hmm.
people might try to call them.
Yep. Yep. Yeah, and especially, I mean, nowadays it's kind of like with the world of APIs, put and delete and things like that are kind of like much more used than before. But 5, 6 years ago, even less than that, we were just using get and post, and I would do a lot of pen testing, and I would try a put, for example, and to allow me to upload a file to the server, and that was the easiest way to get a command execution, right? Um, but then this is an example of one of the things that the web servers and the frameworks can handle, because by default they can, and this is an easy change on their end. By default, they would close all of the other verbs, and you need to proactively enable them, right?
Yes.
So this is more on the frameworks, more so on the developers, more so than the developers, to be honest with you.
Do you think we should try approaching like just like sending like a nice email from a bunch of AppSec people to all the people that make frameworks and like just like in
I
a
love it.
really nice friendly way say from us to you a small request, please disable all of the
I love it.
HTTP methods except for get and post and then make them open them. Like if they code it, have it say, "Oh, that's not enabled. Do you want to enable this for the
Yep.
entire web server?"
Yep. Yeah,
Maybe
I
if
love it.
we wrote like a nice message,
Even a
it
top
just
10
has.
of the things that all servers or web servers should disable by default unless the developer proactively go and enable them.
Oh my gosh, Sharif, we should write a letter.
Let's
Like a
do it.
really nice letter. Yeah. And then you know
Let's
what
do
we
it.
should do? We should see if we could get lots of OWASP and other AppSec enthusiasts to sign it with us and say, "This is really important to us. Will
Yeah.
you please consider?" And just write all of them.
Yeah, let's do it. Let's do it.
Smart guy. Okay, later. Yeah, I like this. So the next topic in this book was session management, and
Hmm.
the main takeaway is don't write your own session management. Use the one in your framework. What are you doing?
Yeah. Yeah. Yeah.
Have you
What?
been on a pen test and seen someone writing their own encryption, writing their own authentication authorization, writing their own session management?
Yep. Uh, I saw Homegrown Crypto twice.
I
In
saw it
during my
once.
career. Yeah, yeah, I got it twice. One of them was in a language called ABAP. I'm not sure if
Oh,
you heard
oh,
it.
ABAP from
ABAP.
SAP, yeah.
Yeah.
Yeah, I had a job for like 6 months programming ABAP, and I was like,
Yeah. So I was reading the code. I was like trying, okay, what is this trying to do? And after like a couple of hours, oh, this is homegrown crypto. Excellent. I saw one. Awesome. So that was a cool find. Session management. What I saw actually is a really smart guy. I have never met him, but I can see his smartness through the code. And he tried to write not only his session manager, he tried to write his own web server in .NET. That blew my mind. They told me, hey, Sharif, here's a .NET app to code review. I was like, okay, great, send it to me. And there is particular things you're looking for. Like it was back then it was .NET 3, I think, or something like that. So there are particular files you look for. There is the web.config. I saw none of that. I was like, I went back to my client and said, are you sure this is a .NET application? They said, yeah, I'm pretty sure. And then it took me a couple of days and realized what's going on. So basically, there was just an interface that not .NET provides, and then you can implement your own web server. And this is what the guy did. And I went back and I asked why. And basically, one of the requirements is that the application needs to be able to be scalable for millions of requests per minute. I was like, oh, wow. That's interesting. So he implemented everything that a usual web server would do. So that was super interesting.
But it wasn't very secure, was it?
No, it was a fun code review, let me tell you.
I feel like unless you're Microsoft or Okta
Yeah.
or some other like the people that make AWS Incognito, for instance, they make identity management systems, and so that's cool. But like, why like reinventing the wheel for every project? It's going to be so expensive.
You know what? I think engineers tend to over-architect. They need to kind of like create the beautiful, multi-purpose, perfect in every single use case application. While I can see their genius in the architect, but when you do that, you open so many attack vectors. I'll give you another example for an application that the Canadian government bought and it spent more than $8 million on. And at the end of the day, it was not deployed. I'm obviously not going to say any more information other than this, but basically, there was a company that produces some sort of a software, right? And then they hired an IT integrator to customize this piece of software to fit that federal department needs. So 4 million here and 4 million here, 4 million for the software manufacturers and 4 million for the IT integrator. And the software was kind of like if you want multi-role, that's great. If you want to do any kind of like workflow, that's great. Whatever you want, you just need to configure it at the back end and add a bunch of modules. But then basically every single bug in the book I could find in that application, all the way from injection, all the way to whatever like the lowest, but everything. And this is because there was so many codes, so many attack surface, there's so many configuration, and you just cannot cover all of these cases, right?
Oh yeah.
Yeah.
Could our wonderful and amazing sound video engineer put up figure 4.2? So this is what a web browser can do when we're doing authentication. So nice person visits our web page and it creates a user session for us. That user session goes back to the browser and the user's like, woohoo, I'm gonna log in. Then it goes back to the web server and the web server's like, hey, I'm gonna destroy your previous session and create a brand new one. If there is a previous session, but I'm gonna create a brand new one for you. Then it sends it back to the user. The user, let's say they're gonna buy a really cool outfit and they're like, hey, I wanna buy this. They send that request over. The web server re-verifies the session because that's a transaction. And we don't want any cross-site request forgery. And then it sends it back to the user. And it's like, hey, we verified it's you. Thanks for your purchase. Here's the little nice thank you page. And the user logs out. And then the web server destroys the session. And I'm bringing this up because this is like, when I was a dev, this kind of picture never occurred to me before. Like it never occurred to me like, oh yeah, I guess that's the flow. And I feel like when we see all the different security steps, do you know what I mean? Like, oh, it does make sense to re-verify there. Like when we see it laid out like this, But when I was a dev, I was like, no, but they're already logged in. Who cares?
Yep.
But it's like, but they're buying something. That's a
Yeah.
big deal.
Yeah.
Just ask any salesperson. It's a big deal when they agree to buy stuff.
So
And
right off the bat, I see 4 bugs that could happen here. Like
okay,
this is my hacking.
tell us. Yeah.
So here's the thing. Visit web page, create user session, right? And this is a bug called
Mm-hmm.
user fixation, session fixation. So what happens is I'm the hacker. I go to abc.com. abc.com will create a session for me in this day and age because they need to track me. So even though I didn't authenticate yet, they will create a session for me. It's called unauthenticated cookie, but they just need to track me, right? So I'm a hacker. I'll take this session, I'll take the cookie of the session and send it to victim, and in a phishing email or what have you. And there's nothing shady about it because it takes them to the website. There's nothing shady. It doesn't take them to my website. And what they do, so for example, I'm going to send it in an email that says, hey, you need to verify your account right now, or you have a refund, or hey, this cool new feature just announced. And it takes them actually to that website that they're trying to go to. But what happened is they will log in using this session ID, and now this session became from unauthenticated to authenticated using the same cookie. But guess what? I know that cookie now because I'm the one who sent it to that victim, to that user, right? Mm-hmm. So that's user fixation. Session fixation right there. The second one that I see here is basically cross-site request forgery. As you said, if they are not verifying that, I could basically easily host a form somewhere and make the user make a purchase that they didn't know that they're making while they think they're playing a game or something, right? So I host a hidden iframe that points to, I don't know, abcbank.com. And inside that iframe, there is a post request. The only thing that it needs is the user session to actually does the transaction. So there is cross-site request forgery. One more bug in here is, as you said, destroys the session. So Java is very well known for this, is that when you actually the session object, Tomcat session object, if you destroys that, it does not invalidate the session. The session is still alive, right? So even if the user clicks log out, the session ID is still valid. And in a lot of Java applications, even till this day, you go back, you hit the back button, you go right back into your session. So
yeah. So we have to be really careful. And this is why using the session management and all the other security features built into the framework, because someone like Sharif has pounded it into the ground already. And like probably a whole bunch of different smart people like Sharif. Not just one. So we're going to bring out our second guest because Aaron has also, thank you for destroying my flowchart. That was really good. No, but like you proved my point of why we need to do those things. So thank you. Let's bring out Aaron. Yay, Aaron! Welcome.
Hi. Can you guys hear me okay?
Yeah, we can.
Okay, good.
Would you mind giving a little intro of yourself so that the audience knows who you are? Because we know, but they should know.
Yeah, sure. So my name's Aaron Lord. I've been doing application security work for 11 years. Actually, 11 years this month in June. I'm currently with Workday Inc. on their application security team. Been there for 2 years, also this month. I run a blog with my colleague Ray called Hella Secure, and that's at hella-secure.com. And you can also find me on Twitter at Hella Secure.
I'm putting it into the chat. I love Aaron's blog. Just to be clear, in case someone's like, does Tanya like it? She loves it. Hella-secure.com.
Thank you.
I don't read that many blogs. I don't have that much time, but I always read theirs. Not only because it's sarcastic and hilarious, but also because the facts are really good.
Yeah, Ray's definitely the more sarcastic one. Definitely.
Yeah. Many times I have sent his Security Champions article to different clients, and I always have to tell them he's just kidding. when he says to just put your phone in your pocket and play electronic dance music quietly so the devs know you are their friend. So I was wondering if we could briefly talk about bounds checking. So does one of you want to explain, like, I guess the concept of overflowing a variable and why that's scary, and then like why we check bounds, or like why we validate input? Like, do either one of you want to make fun of all of that for me?
I've been talking for about half an hour, so I'll let Aaron go ahead.
Sure. I mean, kind of the classic example of that is the like buffer overflow style attack, and that is generally going to occur in non-memory managed languages. The classic examples being C and C++. And that is a case where, now I don't run across it that much, just because I know in my professional experience, I have most of the code I've again had most of my experience with are memory managed, like Java or Ruby or Go or Python. However, this is still going to be a concern in any of these what generally are called like thick clients that run on the system. A lot of them are written in C, C++. Like a lot of video games are written in C++. I know that there are alternatives to it, like Rust. Rust is a C type language that's usually used for thick clients that is memory managed. But what can occur is that in those languages that you have to manage memory manually, you have to not only create your variables, but you also have to create how much memory those variables are going to take up, right? So if you create a string of like that you're expecting 10 characters, but you don't check how much memory is, and you allocate 10 char length of memory, but you don't check to see if that memory or if that value is actually 10 or less, then if it gets a value of 11, 12, 13, 14 or higher number of values, you start to go into the memory stack on the system.
Yeah, for
that
other
allows
parts
you
of the code.
exactly. So that essentially allows you to write computer instructions, which in most cases is assembly, right? And then you can actually begin to control what the computer what the CPU is processing.
Ray says hello, but only to Aaron. Ray is the other half of Hello Secure. But yeah, I feel like bounds checking is a type of input validation.
It's input validation, because there has to be something that's checking. If you're going to be allocating a known set amount of memory, you do also have to check to make sure that the value that is input is also going to be that amount of memory or lower, right? And again, a lot of memory managed languages like Java, the JVM handles all that for you. So generally that is not a concern, right? Like I said, I don't, it's extremely rare that I deal with buffer overflow, especially a lot of the companies I've worked with have been kind of mostly web-based presence companies. Yeah. And in general, a lot of those web-based applications do not use like non-memory managed languages like C and C++.
So in the chat, Ray is being silly and saying he once validated his input and he didn't like it at all.
It's funny. It's funny.
So thanks. I hated it.
But I have to say that, like, if every single dev did awesome input validation every single time, wouldn't like we probably not have jobs? Like, don't you think that maybe like, or at least that there'd be maybe half as many data breaches? What do you two think?
Well, input validation is a very good first line of defense. Almost never, in my experience at least, it was the only line of defense. I mean, obviously, one principle in application security is multi-layers of defense. But let's say that in a particular situation, you just have one layer to put. So in a case of SQL injection, that would be parameterization, right? You're in a pretty good place, even though you have one line of defense. Mm-hmm. Input validation is a very good first line of defense in my experience, as far as I remember, it has never been enough for any single vulnerability. I don't know, Tanya and Aaron, what do you guys think?
I
Uh,
feel like if I only got to choose one defense, I would choose that one.
If you
But
want to
I
cover
agree with,
as much as if this is the only thing that you can do, well, you don't have an
yeah,
option.
but you shouldn't only do one thing. I agree
Exactly.
with you on that too.
Yeah.
Aaron?
yeah, I would agree that if I had to choose one, it would probably be input validation because it is kind of the first line of defense. But you're also right, is that in all these cases, we have to think about defense in depth
Yeah.
and think about the layers of security as opposed to just having one defense, because it also comes back to what's the weakest link in the chain, right? And if your input validation is super strong, but you miss something somewhere else, it may invalidate any protections you did for input validation in the first place.
Such a good point.
Mhm.
In the chat, Ray is asking, how do you validate free text or a last name or an address? Does anyone want to take a crack at this or?
It's tough. It's tough to cover all the cases. You throw in uh, kind of like multi languages, like if your application is supporting different languages, then it becomes
Like
really
spoken
tricky.
languages.
Spoken
Spoken
languages, I'm
languages,
sorry, yeah,
right?
like
Rather
I
than
don't know,
programming languages.
rather than so not just English. That's what I mean.
Mm-hmm.
It becomes really tough. In my experience, very few organizations or developers are able to do it without a lot of sacrifices. That's why I'm kind of like in the oddball of, well, yeah, input validation is good. You should consider it as a first line of defense. But if you do input validation really well, one, it's going to become very painful. Two, you'll have to sacrifice a lot of functionality. And to be honest with you, something like cross-site scripting, I can still do it with your input validation, unless you have very strict input validation, and in this case, your functionality is going to suffer a little bit. But I'm the oddball there. What do you guys think?
I know it's also sad. So, and then Ray does bring up a good point as the difference between last name and address versus free text. All input validation is not created equally either,
Mm,
because something, if you were to validate a first or last name or a phone number and email address, those have kind of more exact value types. So you
yep.
can
Mm-hmm.
actually, and again, talk about the difference between an allow list and a deny list, right?
Hmm.
Generally, the deny list means you have to be smarter than the attacker, and you have to be constantly updating this list of like
Yep.
what's bad, right? So when we talk about making an allow list, you say, okay, for a last name, you would only allow letters and maybe certain accent characters,
Hmm.
apostrophes, dashes, things that people might have commonly in their names. Phone
Mm-hmm.
numbers, email addresses, even easier because you can look at, or I would say even an email address even has like an RFC tied to your exact
Yeah,
formatting. So you can,
that's easy. Yeah,
and then
yeah,
you can write an exact regex to what that's supposed to look like.
yeah.
Free text, if someone's writing a bio about themselves or a forum post, they can write whatever they want, right? So how do we input validate essentially anything? And that
Mm-hmm.
becomes a big hurdle.
Mm. Yeah, so if I might add, so things like first name, last name, email, address, maybe, are kind of easier. Now, free text, and there's a lot of applications that allow their users to enter HTML, and now it gets really
Mm-hmm.
tricky, right? And so, in a lot of cases, in a pen test, you say, well, people can put cross-site script, JavaScript in here. They say, yeah, but this is by design. So, as an engineer, as a security engineer, what do you do?
Yeah.
The engineering team kind of like got the card, which is by design card, but
Mm-hmm.
that this is an invitation for a lot of bad stuff. So
What I've seen some people do is if they have to accept that, they implement a WAF, a web application
mm,
firewall, and they specifically use the WAF on things going out.
yeah,
And so the WAF blocks specific things. So again, a WAF is a block list. It's a list of that looks bad, so you're not allowed. But that can stop a lot of things. And also output encoding can stop, but if it has to be JavaScript, then if you output encode it, you ruin what the user did.
Yeah.
Yeah, that's definitely a mess for
Yeah.
sure.
Yeah, and a WAF is challenging because generally a WAF can sometimes be a pretty complex tool, right? It sometimes might require an entire human resource to manage it for who knows, like 30 to 40% of their time, especially if you have a large enterprise that deploys WAFs in large clusters, right?
Oh yeah.
So I always
I went in
have
to consult somewhere and they had 4 full-time resources on their WAF. They did
yeah.
control many different organizations, but 4 full-time resources is a lot of money.
Yep.
Yeah, so it's the balance between like effectiveness versus how much resources it takes, both human and finance resources, to actually support this.
Yeah.
But I think for me, I've always starting as a pen tester and stuff. It was always a kind of a joke, like getting past WAFs and stuff was like trivial. So even some of the best configured ones may not be 100% foolproof, but that could be true for a lot of stuff.
Yes, I remember doing a pen test once, and I was not an advanced pen tester. I was a junior pen tester, and saying, like, not trying to be insulting, I'm like, is it on? And they're like, we think so. And so we spent the whole night, like, getting it to turn on and actually block stuff. But it was actually a really good time. But fun times aside, I have more questions. Error handling, logging, and monitoring. Why do custom apps need to log? Why does security care about logging from a custom app? Don't the devs just care? Why does security care? Do we have any thoughts on this?
Aaron, what do you think?
Well, it's funny you say that because we kind of take it for granted, right? We think like, oh, well, almost all apps have logging capabilities and abilities to put those logs wherever we want it to be. And it's funny to kind of look at it from a point of view of like, why do we do this? And sometimes I don't even think about it anymore because it's just one of those things that just people do. And it's funny to think about like, well, what would happen if we just don't, right? And what would that look like? And in my head, that seems extremely scary for the reason that we wouldn't know what kind of state an application is in. It could just be running, and we have no idea what it is currently doing, right? Because there's a difference between what we believe an application is doing versus what it's actually doing. And if we don't have those logs to know that, then we're just ignorant to what's going on. Again, a lot of these security issues is a form of like abusing the application in a way that it wasn't intended. And if we can't visibly see that, then we don't know what's occurring. It's also the case that the developer resource is usually not the one who is constantly monitoring what's going on, right? Usually there's an entire team, usually a security operations center or a SOC that kind of does that job, right? So they need that information to do their job, right? They need those logs. That's what tells them what's going on at any given time.
Sharif, what if there's a security incident? How do we investigate if there's no logs?
That's exactly was my point. Aaron started this thread by saying somebody else, probably if there is an incident, the developer is not the one who's going to go in and figure out what happened. It's somebody else, and if that somebody else cannot figure it out easily from the logs, then we would not know what happened. And in a lot of security incidents, what make or break a company, not the fact that they had an incident. All organizations have incident. It is their response and how they respond and how fast they respond to the incident. So the logs is a very critical element for the incident response team to basically understand what happened, how it happened, and respond to the incident in a timely fashion. And usually that what makes or breaks the company when a bad incident happens.
Oh, yeah. Oh, yeah. I agree with both of you so much. You both made great points. I was wondering if we could briefly look at the most amazing flowchart I have ever made, figure 4.1. So I wanted to name this Input Validation, the Musical. So you know how people will say like Spider-Man, the musical, but they said that was silly and they're probably right. So instead it's called the flowchart. They wouldn't even let me put an exclamation mark. I'm like, I'm trying to make dad jokes here. But if we look at this, like how do we want to go through the steps? So if you're listening later to this, we'll say all the steps so that you know. But does it? Do you want me to talk to it, or is anyone dying to talk about this?
I can walk through it. So starting from the very top, validated input is what you expect. If fail, reject input. If input and then moving to the second layer, if input triggers transaction, then verify CRF token. If input is a link for forward or redirect, verify that's actually an approved list. If input is used in database query, use parameterized query. If input is sent to the screen, one of my comments here is what happens if it's a few things. So could be a triggering transaction and going into the database. So
Yeah,
so that is where things could get a little bit dicey. But
yeah. You have to do a bunch of steps then.
exactly. So um, like the way I like to look at it is as we kind of like touched on before, input validation is a very a first line of defense. In my opinion, it's a way to deter the hacker from continuing, because nothing more frustrating to a pen tester than an application that does not accept something other than what it should accept. So an email, I cannot put anything else, and it tells me, oh, this is not an email. This is very frustrating for that attacker. So kind of like a script kiddie, having a very good input validation framework will deter that script kiddie. Will just move on to the next application. But it's a pretty good framework. That this flowchart is a pretty good framework of what do I need to validate in these cases.
Yeah.
Yeah.
Aaron, do we need to be perfect? Does our app have to be unhackable, or does it just need to be like Sharif was saying, really, really annoying so they go elsewhere? What do you think?
Yeah, I mean, to the first part, to say that any kind of technology is 100% unhackable is just
Mhm.
kind of a false premise, right? Um,
And it's
it's
asking for trouble.
Yeah, it's essentially it's because even if you tell yourself that or you tell someone else about that is just a it's like wishful thinking, right?
Yeah.
Um, I mean, there are cases where like there's this funny like picture I remember seeing. It's like 100% unhackable application. It's just a picture of someone cutting the Ethernet wire and just saying like, "Yep, can't get to it. 100% secure." And it's funny, but I agree, right? That makes it 100% unhackable unless you have physical access. Then that's different. Um, yeah, it's hard to say that you want to try to get obviously as good as you can possibly get, and it's really hard to even know what that number is, right? Can we say it's 99% unhackable? It's hard to say because sometimes the vulnerabilities remain hidden. We've seen how all of these like much older applications, um, like when Heartbleed occurred in, I think it was an OpenSSL, I believe, and when was it Shell Shock happened. Those are very old apps that have been around for a very long time, and we're still finding vulnerabilities in
Mhm.
them today. Uh,
Yeah.
so yeah, we can say that those are 100% secure because we know now that they're not. Um, it's just the unknown, right?
Yeah, I feel like it kind of depends too on what your risk is, right? Like
Hmm.
if you're a little tiny flower shop that, serves this small community and you make a website, like if you're handling credit cards, that's the danger zone. But you could totally just make a Shopify store and like you just have like a front web pagey web appy thing, but then all the hard work's done by the Shopify team, right? And you can
Hmm.
transfer that risk. But OpenSSL is depended upon by millions, right?
Hmm.
So I feel like, you know what I mean? Like if you're on the Microsoft team making Windows or you're on the Google team making, I don't know, like their Authenticator app, like there's like different importance and different risk and different attackers, right? Like my company has a website and it is WordPress. I know what you're thinking. WordPress. But anyway, I'm actually going to publish my little pen test and my security analysis I did of it and how we hardened it when I get my butt around or actually writing out the blog post. But anyway, but like my company is all we're protecting is our intellectual property and then personal employee data, which never goes anywhere near the internet, right? So we've like transferred our risk. So all the credit cards are handled by a SaaS provider. And then it's just a website. And if like the website goes down for a day, that will be extremely annoying. That's the level, right?
Mm.
So like I don't want it to be wide open. I don't want someone to deface my website, but it doesn't need to be like Solar Winds.
Hmm.
Solar Winds has like real attackers that actually care what they're doing, like nation states or advanced criminals, etc. Like I feel like it really kind of depends on. We're getting very interesting comments
Hmm.
from Ray. Um, very briefly, Ray says you should totally say your app is unhackable because then you'll get lots of free penetration tests, except you don't get the reports. I'd like to note, Ray, and that he teaches his devs to build defensible web apps. I really like that. Like, yeah, I like that idea. What do you two think about Ray's comment about the free pen tests?
Well, usually the examples that I've seen when somebody said unhackable, they are coming out for a PR stunt. So
Yeah,
what they get is the total opposite of
yeah.
what they were going for. So the free pen test is, I don't know if it's gonna cut it for me at this point. Yeah,
Yeah,
Yeah.
yeah, we can leave that.
yeah.
Um,
The Go ahead, Aaron. Sorry.
sure. Well, one thing I was thinking of too on that flow chart that you were just showing as well
Mhm.
is that um, the audience for that flow chart does matter as well,
Mm,
because input validation for, say, a back-end server that interacts with a database and all this stuff, this is again, this is great information for them. But if I'm talking to a front-end team and they work
Mm.
purely in React and JavaScript, it may not be as useful, because we know that if they try to do a lot of this input sanitization or input validation on the client, we know that that could be easily bypassed. In the same
Good
case
point.
where API developers, depending on where their API is in the chain, may not want
Mhm.
to output in code because they may be
Mm.
output encoding and then another API picks it up and then output encodes and you get double output encoding and then it messes up the
Oh
results.
yeah.
mm,
Oh yeah. Good point.
So
Excellent
it just
point.
goes to show that a lot of this stuff is very contextual, and why kind of sometimes we
Yes.
need to. It's hard to have like one thing just for every team. For like,
yeah.
here's the
Yes.
security Rosetta Stone, follow it, right? It's very hard to
Yes.
make that.
Yes. Oh my gosh, yes. Writing a book, it was so hard because I'm like, well, what about this and what about that? And they're like, your flowchart cannot be 10 pages, Tanya. No one wants to see that.
Yeah, and there's a limit. You can only go down those edge cases so far.
Okay, so I want to go over the exercises at the end of the chapter. So again, we're reading Alice and Bob Learn Application Security. We're doing chapter 4, which is secure coding. And I have two awesome humans on this call with me, which is I have to say I've been really grateful for how many people have come on these calls with me. So thank you both. And thank you to everyone that has been on these calls with me and who will be throughout all of 2021. We're going to finish up just before Christmas. So just a little gratitude from Tanya to both of you. Okay,
Pleasure.
Of course.
exercises. Number one, when should you use your own identity on the network, a user account, so like Aaron or Sharif or Tanya, versus a service account? Give some examples. I can start. Like if I'm going to log into my email, it should be my account, not a service account. But if I make an app and it has to call a database, it shouldn't be Tanya's account that does that. I should make a service account for my app to talk to that database and talk to, I don't know, whatever else it talks to. What do you two think?
I'll let Aaron answer that one.
Sure.
Okay.
So usually when I'm kind of disseminating what an application is doing, I tend to talk about what is interacting with something as actors, and there can be multiple types of actors, right? There's a human, like in general, there's two major ones: a human actor and a kind of machine actor, right, or a service. In general, both of them, it's very obvious that like the user should be authenticated, right? We need to identify who this person is, username and password, two-factor auth, whatever it requires to identify that this person is who they say they are. But we have to do the same thing for our machine accounts or service accounts. And that can be APIs that call each other to gather information, right? Those also need their own accounts to determine they are who they say they are, right? Because if an API is exposed in a certain degree, technically anyone could call it and try to get information out of it, but they should be able to identify who is who, right? So my classic example of that is like what I did recently is I wrote an application that interacts with GitHub, right? So it basically does some automatic cloning and scanning of uh, like repositories. But of course, to clone something, it has to have not only an account, but also has to have like a public-private key pair. So that has to be set up on behalf of that service to be able to have that service account call it, get what it needs, and be able to authenticate to GitHub.
The other side of that is like what are the requirements? So obviously for a user account, what happens if you're using a service account and the service account have a bunch of high privileges? So basically, if there's a vulnerability, then you're getting the privileges not as your own user, but the privilege of the service account. So that's one thing to think about. Now, we can have multiple service accounts with multiple sets of privileges. So that's another reason. Does the application require the identity of the user for logging, for tracking, for anything of that, for accountability, for any of that sort? So I'm not sure if there is a kind of like a clear-cut answer, but it's 100% contextual. The only security, there's two security, when I saw this question, there's only two security requirements here, is the least privilege, the concept of least privilege. So which one of them should be least privilege should be used, and the other one, where we need the user account, we need the user identity, we need the user to be able to track and log their actions on the in the application.
I agree. It also helps with, I mean, if you see Tanya's account in the middle of the night trying to delete production databases, versus if you see a service account, trying to access, let's say, online storage in the middle of the night. What's more likely, a real action versus someone has somehow gotten into Tanya's account, right? Like it can be, especially with the timing, because Tanya does not like to work in the middle of the night. But not everyone knows that. But you could
Yeah.
probably set up some sort of thing that says, like, if employee accounts do from here to here, it's probably not an employee. It's probably something bad happening.
Yeah.
I have more questions for everyone in the audience. So audience members are allowed to answer this too. This next question is, okay, so at the beginning we talked about selecting your framework, right? Well, so I'll read the question. Number 2. Explain possible reasons or situations why C and C++ are still widely used in our industry when Rust, a memory-safe language, exists. Try to think of a few reasons. What do you think are some possible reasons that people are still using C and C++ when they could just use Rust instead and have, like, not have to worry about memory?
There's a lot of reasons. For example, the automotive industry. The automotive industry is 100% C and C++, and it's not as simple of a switch because there's a lot of libraries that were written 15 years ago that nobody want to rewrite again. That has been written in C, C++. There's all of those millions of 6 million C, C++ programmers exist today that will need to be retrained, all of that software to be rewritten, etc. So think about everything that is not online, from automotive, from firmware, from IoT stuff, from servers, from all of the stuff is written in C, C++, and they rely on other C, C++ libraries that rely on other C. There's a whole supply chain of C, C++ that cannot just go
Yeah.
away. The other thing is how many, if you put an ad for a Rust developer tomorrow, how many applications are you going to get versus if you put an ad for C, C++? That's another thing a development manager would think about, right? Is the availability of talent, right?
Yeah. Yeah. Also, like your point of having all those dependencies that are already written in C, those probably
Mhm.
don't exist in Rust. What are you going to do? Write all your own libraries? How much is
Yeah,
that going to cost? How long is that going to take?
it's tough. I mean, these languages. I mean, these languages. Like I'm not familiar with Rust, to be honest with you. Um, but if the language is solid, it will make its way into, like, look at JavaScript, right? 12.4 million developers nowadays. 5 million of them just joined the community in the last 3 years, right? So that's mass
Really?
adoption. Yeah, that's the stats that blew my mind. Um,
I,
so
I, I've also heard that Rust is, it's just hard. I've heard it's really hard. Like, I remember seeing someone say, oh, at a conference talk, everyone's like, you should use Rust because it has all of these benefits. But then in reality, people are like, I don't like programming in it. It's really hard. And I have not coded in Rust, so I can't really comment.
me
But I've
neither.
coded in C and C++, and I think I learned them when I was 16 or 17, and I was off to the races in, like, I don't know, I was making card games. And also, I made this testing tool where it was like to help every single person in my class take a math test, but they all had different numbers so no one could cheat. And then if they
Mm.
failed, it flashed a big L and went loser and beeped so everyone knew. Because that's what my 17-year-old self thought would be motivational.
Yeah.
Um, but like I did that at age 17, like that. And like people, from what I understand, it's like kind of hard. So
Yeah.
maybe there's that too, right? There's lots
Yeah.
of reasons that
I,
are
I,
out there.
I don't know Rust, to be honest with you. I don't know if Aaron has some experience with Rust.
No, no, I don't have any
Yeah.
Rust experience either. But yeah, you basically pointed out pretty much the major things about why we need still these languages is because of just its history and how much of a footprint it already has. It's
Yeah.
still the 800-pound gorilla when it comes to that type of development work.
Mhm.
And Rust is just starting. So who knows? And it takes a while. It could be a
Yep.
completely new generation before we see a transition uh, to Rust or something else that might come along at the same time. But yeah, when we have all those huge libraries of components that are written in C and C++, that you have to use C and C++ to use. I'll go back to the example of like video gaming. Video game engines are generally mostly still written in C and C++. So if you want to use like Unreal Engine 5, I think you still have to use C++ to use it.
Yeah.
All of the
Yeah, that's a
graphics
really good point.
Yeah.
software, all of the graphics software.
So I want to ask everyone in the chat to answer this, and everyone when you're listening think about this, but like, what's your favorite programming language and framework and why? And I'm going to answer first. Mine is .NET and VB.NET because it is the one I have done the absolute most of. And because I can download the IDE for free. But that's my actual main reason. Like, I used to really, like, if I'm going to write a script, like, back in the day, I learned Perl, and I remember just loving Perl. Like, I instantly could just do whatever I wanted in Perl. But you can't really build web apps in Perl, so I feel like .NET's better. What do you two like?
For me, it really depends on the context. So web app, I like C# quite a bit. JavaScript is super easy to get something up and running, scalable, asynchronous, etc. If you're dealing with ML, anything to do with machine learning, then the sheer amount of libraries, ML libraries out there makes you use Python. If you're doing something that needs to be super fast, back end, no web at all, C++, you cannot do that in JavaScript. You cannot do that in C#. So C++. So to me, it really depends on the context. But C# is a fun language that is nice to use. It's very easy. There's a bunch of ecosystem around it. I love what the framework did from a security perspective. Every new version of the framework provides a lot of new security features. Sometimes they go back on them, but that's a different story. But yeah, if an absolute answer is what's required, it would be C#. But really, it depends on the context.
Aaron, do you play favorites?
Yeah, I mean, most of my experience is in Python. Because most of my development experience is writing security tools. So I'm mostly kind of just open to whatever I want to use. And Python seems to have a pretty big footprint when it comes to like security developing, like or developing security tooling. It seems to be the one that I've run across the most. So still like Python, and I really love using Python with Flask. The Flask is basically an HTTP server framework for Python that's super easy to use, and it takes you like less than 5 minutes to set up a quick local web server just to test like an API. I've done that multiple times just at Workday. And while I don't work in it personally, I do a lot of analysis on Java with Spring. Lots of Spring applications. The Spring is great just because it's just has a lot of stuff built in. Now, using these frameworks just out of the box doesn't immediately mean that they're secure, right? There's still some configuration that goes into it, but especially from my point of view, as analyzing this code for security, it comes down to like, okay, well, did you do XYZ configurations? Then usually you're just good to go. I don't have to do too much tracing through multiple files and components to figure out if something is, if a security requirement's been met, right? Also a fan of Ruby on Rails as well, even though Ruby on Rails is nice because it kind of does a lot of that stuff for you. As, again, someone who has to do secure code review for Ruby on Rails, Rails does a lot of like magic where you just basically call one line and it just does a ton of security stuff in the background. And sometimes if you just don't know what it's doing, you don't realize that it's doing all of those security functions for them. So as long as you know what this stuff is doing, and it comes down to being able to read a lot of this documentation.
Funny story. So back in the days, I got an application to review. It was Ruby on Rails. It was my first time to review Ruby on Rails. So I said, how many lines of code? He said, well, 12,000. I thought, yeah, that's a small application. A lot of my experience was in .NET and Java. So 12,000 in the .NET and the Java world is like nothing, right? So I said, yeah, this is just a few days. And then you go into the code and you start reading it. And as Aaron said, one line is a lot of stuff happening in that one line. So just, so I regret my decision to just assign it a few days for this. Very soon after I started the security code review. So yeah,
Oh, poor Sharif.
Yeah,
I learned my lesson.
it comes down to like not even reading the code. You're just realizing, well, now I have to go read a bunch of Rails documentation to see what is this line actually doing. Just to ensure that it's doing that. Like I looked at a Ruby on Rails product like a year ago, and I had to look through a ton of Rails documentation to see what it's doing. Because like, for example, I wanted to know what type of like encryption libraries it was using for certain things. So I had to go down this like tree of documentation to see like this component does this component, until I finally got to where I see what algorithm it's actually doing to do this encryption. It was either encryption or some type of secure randomization library. But I wouldn't know that just from looking at the code by itself.
We have an awesome question in the chat. Are there any good resources, learning resources for learning Ruby on Rails for security code reviews? And I would say, so there's this tool called Brakeman, and that is what a lot of people use to do SaaS, like so static application security kind of testing or analysis specific for Ruby. Does anyone, and so I would suggest learning Brakeman, and that could bring you from there. I believe Brakeman's free, which is also pretty cool.
Yeah.
Is it not
actually
free, Sharif? Your eyebrows are telling me a different story.
Actually, I'm not sure. I'm not sure if it's free anymore. I'm not sure, Aaron, if.
I mean, as far as I know, it's free unless they added some type of premium thing recently. I don't think they have. I actually looked at it recently because I'm evaluating some of these SaaS tools to be put into another tool that we're building. And yeah, Brakeman's actually really great because it just, you just install it on the command line, run it on a repository, gives you results, and you can have the results in multiple formats like JSON, that kind of stuff. I did learn though that Brakeman is specific to Rails, so you can't just scan Ruby code without Rails. So it's only a Rails scanner. That was something I actually had to learn recently because I hadn't used it in a long time. So I was like, I had to look at a Ruby app that was just Ruby, and then realized when I ran Brakeman on it, it was just like I can't find the Rails file, and I'm like, oh, well, great. I don't really have anything really to scan this Ruby. It's just straight Ruby code now. So, but I still had other scanners to fall back on.
They are still free. Yeah, they are still free. Ruby Brakeman scanner.org.
Yeah, and Brakeman is spelled BRAKE, man, MAN, scanner, and then .org for those listening. Okay, so that's awesome. So a question I get asked constantly is, I want to work in application security. Which programming language should I learn? And I'm like, the one that your devs do. That's the only one that I think you should care about. And they're like, well, which one's the most secure? I'm like, ooh. Do we have opinions on which framework or which programming language are the most secure? Because I can certainly point out some that I think stink. JavaScript. I have hard feelings with JavaScript because of how many incidents I've had to respond to, how many fun evenings it has broken up with security incidents. But like, we'll answer Ray's question later, but do either of you, like, I don't think we can name a most secure programming language, but what do you two think? Maybe we can.
I mean, I try to avoid, because if you give a blank answer, people think that you just start writing in this language and everything is just going to happen for you. But out of the box, we can answer a question is which language framework combination provides you more secure features out of the box compared to things that you have to do yourself.
So
So,
smart.
so in that case, I find that C#.NET, Ruby on Rails provides the most. And recently started the Spring as well, Java Spring. That's the Spring
Yeah.
framework in general. So
Yeah,
that's
they've
as
upped
far
their
as
game.
yeah, quite a bit. Yeah.
What do you think, Aaron? I'm
Yeah, I
nodding. I'm like,
mean,
I disagree with Sharif.
no, I agree with those. I even wrote down, I was like Java Spring, Ruby on Rails. Um, Again, it comes down to making sure that number one, you're using the correct components, especially in
Mm,
Spring. Spring is broken up into like a dozen or more components that you have to kind of like use piecemeal and combine into your app. So you have to make sure that you're using the correct ones, especially in this case, Spring Security. Gives you a lot of the security libraries to do some of those common functions like authorization,
mm,
authentication, and some of those, especially those two. Those are the main two with Spring Security. Um, but you're right; it's hard to say like, oh, this is the best.
yeah.
It's really hard. I would say one thing that helps determine what is better is probably the combination of the maturity of that language and framework. So if it's been around for a while, and also the community around that framework and or language. So if it has, if you see a framework but it hasn't been really maintained in the last year or two, then a lot more questionable than something that is maintained almost daily.
Yeah.
Right. So that's probably one of the big key indicators is just how good the community is around it
Community or even like a company, like with .NET
and company.
specifically,
Yes.
like it's owned by Microsoft. So there are people who are paid to make sure that it's secure. Does that make sense? Versus like Node.js, which I believe is it fully volunteer based, or do they now have some employees? Because I think Node.js got acquired or something, but it's still mostly volunteer run. That's a lot of work to depend on people's spare time. Just look at my open source project repos and you'll be like, I have more I have more
Yeah.
questions.
I'm not sure about Node.js nowadays. I mean, I have to assume it's got to have a lot more structure around it than it would have in the past because it's still very widely used, right? So,
Yeah.
Oh yeah. Oh, it really is. It really is.
I mean, correct me if I'm wrong. I believe that Angular and React is still based on that framework, correct?
I'm not sure.
Uh,
I don't know the answer to that.
I'm not sure. I think
Or at least it uses like NPM at least.
yeah, yeah,
Yeah.
yeah. Node NPM is sorry. I mean React and Angular front end systems. Node is a back end. It does a bunch of things, and it has its own flavor of JavaScript as well. But I think it's still open source. I don't know if somebody acquired that.
Yeah.
I believe it's under the OpenJS Foundation, whatever that is.
Not sure.
NPM is
Yeah.
what was acquired by Microsoft.
Oh, okay. Okay, I get it. I get it now. Yeah, the
Yeah,
package management thing.
yeah, NPM. Yeah,
Um, Yeah, so Ray is helpfully adding that every Node app has like 400 third-party dependencies, and kind of agree. And Ben was adding that if someone uses Ruby on Rails but they misuse it and they don't use all of the cool built-in security features, you can still make a really insecure app. And I think
exactly.
I can say we all agree, definitely. If you misuse any, even the most secure lockdown programming language, you can inadvertently make vulnerabilities. I have another question about user sessions.
Mhm.
Why do we need to protect them? So this is question number 5. Why do we need to protect user sessions? Why do we care?
I mean,
I know you both know.
the easiest way to look at user sessions is this is your identity for a particular application online. So this is kind of like your password, sorry, your passport. Maybe password is not a good example, but it's your identity for a particular application online. If it gets stolen, your identity is stolen for a particular application. Now, if that identity is a Gmail or a Microsoft identity or whatnot, guess what? It is the entry into multiple applications that are using Gmail as their identity management. So just as simple as basically your identity is stolen.
Yeah. Okay, so the next question, which is a follow-up question, is for Aaron. So Aaron, if an attacker were able to get a hold of someone else's session while they're logged into their online banking, what could they do?
So, I mean, one of the classic analogies I remember using when talking about how sessions work is kind of like when you go and there's like one of those coat rooms, like you go and like put your coat somewhere and they like kind of keep it for you until you leave. You give them your coat and they give you a little ticket like with like a number, right? And then that coat has the same ticket. So if you come back, you give them the ticket, you get your coat back. But then imagine if someone takes your ticket, in this case, like a session ID, they could just walk over to that coat room, say, give me my coat, and you steal someone's coat.
And what if their car keys are in their pocket?
There you go.
Essentially, yeah, like a car key is essentially like a session. It's like a session to your car. It unlocks it, starts it, and you drive away. So if you're on a banking application, and I steal your session identifier to it, I could essentially just be you in your bank account, and I can do whatever I can do. I can do anything you could do in that same logged in session. Hopefully, there are cases where sometimes some really secure functionality, like changing your banking details or your personal details, might also require you to re-enter your password. But if that's not there, then yeah, I can just be you on this website.
Yeah. Like you could take out a mortgage maybe, or you could transfer all your money to the malicious actor's account, or you could I don't know, you could file a loan request with falsified information and then like ruin that person's credit potentially. Like there's so many things you could do that would be bad. And I feel like maybe when devs understand like the risk of if a session is taken over, like all the terrible things that could happen, they're a lot more likely to be like handle it more carefully. Does that make sense?
There's so many things
So
that can happen. So yeah.
have you seen some specifically bad ones you want to tell us about? You don't have to if you don't want to, but you have this knowing look.
I mean, I'll give you a simple example, right? Like one client, it's a B2C application. It's one of Alexa's 1000, top 1000. So it's pretty popular, right? And their account their passwords was using 6 characters and no restriction on those 6 characters. So 1, 2, 3, 4, 5, 6 would work. Obviously, we flagged that as a problem. And they came back say, well, our users are, I cannot, like their users that are like not very techies, right? So they do not want to impose strong passwords on them. So anyways, we see our role as security as flagging the risk, and the business can accept that risk or eliminate it or mitigate it or what have you. So 2 years later, 800 accounts were stolen because of the weak password policy. And they came to us and said, why didn't you guys didn't tell us about that? Yeah, we did. 2 years ago, we did. You guys chose to accept the risk. That's so yeah, just a simple story to the need of protecting this identity.
Yeah, the same thing happened to me. Similar thing.
Yep.
Yeah,
Yeah.
I feel like stories really can help people understand like this could happen to me or this could happen to our customers or my teammates or our business. Like that's why I
Yep.
included so many stories in the book.
I like your story about how I can remember Bob or Alice. They wanted to change from struts to Spring, and it was going to cost, I can't remember what. And then the C-level executive said no. But then when they put it in the sense of numbers, we had an incident. The incident cost us X. We changed to Spring. Now we're going to get less incidents. We're not going to incur that cost. That makes a lot of sense for an executive, right? So
Yeah.
we as security professionals need to use this language more often.
Yeah. Yeah. Well, I remember the reason that came to be and that story came to be is I had gone into a meeting and told them basically the sky is falling. And they're like, it doesn't really sound that bad.
Hmm.
Go away. And after I was lamenting this to my director at the time, and he said, Tanya, if the sky's really falling, you can't just be Chicken Little and be like, oh, everything's scary. You have to explain to us what could happen to our organization, why this could hurt Canadian citizens, why this could harm, our main business goal, or how much money that this is going to cost. You can't just say it's really, really, really bad because you
Yep.
sound like the other people on your security team and we never approved their crap either. So then I
Yep.
came back the next week and I was prepared. And that is how I got permission to launch my first AppSec program. I showed them how
Cool.
much all the
Yeah.
incidents cost and how much it would cost to do the program. And they all looked at each other and immediately approved it on the spot, which I was not expecting. I thought I'd have to argue for weeks. And they said, granted. And they did like this little kind of like as though they were tapping me on the shoulder. And I was like,
Hmm.
did that just really happen? They're like, you spoke our language. I was like,
Hmm.
oh, I must learn the executive language.
Absolutely.
I have more I have more questions though. Okay, number 7. If you were going to explain the difference between authentication, so auth-n, versus authorization, auth-z, but to a person that's not technical, so a smart person, but not a person that understands security or is overly technical, how would you explain auth-n versus auth-z?
Like very simply, I'm walking into a building and the guy or the girl at the building, the security guard, asked me, "Who are you?" And I say, "My name is Sharif Kusa." He said, "How do I know that you're Sharif Kusa?" So I pop out my driver's license. So now they know that I'm actually Sharif Kusa. Great. So that's authentication. Is
So it's who you are.
who am I, and actually proving that I am who I say I am, right? Authorization is basically, okay, I'm Sharif Kusa, but what do I have access to inside that building? Am I a guest and all what I can get access to is the front desk? Or am I an executive and get access to this particular, or what do I have access to in this building? So that they can walk me to, or give me access to the pieces of the building or the locations of the building where I get access to. So that's authorization.
Nice. That was such a good, clear answer. Was there anything you wanted to add, Aaron?
Um, no, I mean that was pretty much perfect. I mean, if the other analogy that I've used in the past is like a hotel room, right? So like once you walk up to the front counter and you say, this is me and I have a reservation," the authentication piece is confirming you are who you say you are and that you confirm with your, usually the driver's license and the credit card, and you're given a key. That's the authentication of the key. But the key itself gives you authorization to only your room
Mm.
versus all of the rooms in the hotel. So again, if we look at like
Yeah.
the cleaning staff, they would have more of a master key that lets them into all the rooms. They have authorization for all rooms to clean, right? But me as a guest, I am authenticated to be a guest here, but I'm only authorized to be in my own room because of the key I was given.
Or I lied and
Oh,
I don't have reservation at all, and in this case I get no room.
Yeah, so like that's like an authentication bypass, right?
Yeah.
I
But
really like in the chat Rick's explanation of authentication is who am I and
Mm.
authorization is what I can do. It's like the
Excellent.
most simple explanation, and also like everyone loves your answers, both of you.
thank you.
Um, yeah, both of you have great analogies. Okay, so now I have a question that is, I'm obviously very biased in the way I'm going to ask the question, but bear with me. So, number 8, should C-level executives have special privileges on your network or other computer systems? Like CEOs, chief marketing officers, chief financial officers? And if so, why should they have special access? And if not, why shouldn't they? And what types of privileges would you give them?
Done.
Right?
in general, right? But I think it comes down to uh, access should be driven by, amongst other things, should be driven by one, your role,
Mm.
and your role or your job, right? So what do you need to do your job, right? Generally, the C-level executives are not the ones who are going to be logging into these servers themselves and managing them and maintaining them. So if they're not doing that job, they clearly don't need to have that access.
Yeah. Yeah.
The other part that I would add on top of this, if you have um, you need redundancy with access, just to mitigate against the risk that if the access is within one person, that's a lot of risk. So let's say that you're a C-level VP of information technology, right? And under you are all of the kind of like the admins. And there's one admin who have access to everything. That admin disappears. It's a huge issue. So in this case, the C-level person or the VP might have access just for redundancy. But if there's two people, two admins who have access to everything, then in this case, there's no need for redundancy.
Yeah, that's a great point.
All of the people in the chat are like, yes. I have had so many C-level executives try to bully me into giving them extra permissions. They're like, could you just turn off my web filtering? Because it's really annoying and I want to surf blah, blah, blah website that's not approved. I'm like, are you kidding? You're the number one target. You and your administrative assistant are our number one targets at our organization, or the sysadmin. And I actually, so like I'm the CEO of my 5-person company, and someone tried to spearfish me this week. I have to say, honestly, I felt really flattered that someone would even bother to try. I was like, oh wow, look how special I am. Someone's exerted effort to try to, what do you think you'll possibly get?
You've made it.
We're a startup. We don't have that much money to steal.
I have the
But
perfect
yeah,
example for why you
yeah.
shouldn't do this. It came on the news and somebody posted in our Slack. I'm trying to find it, but basically it was a mid manager in the Ontario government, and he was able to exfiltrate millions of dollars by turning off. They had controls. It was a grant for youth or something like that, and there were
Oh no.
controls not to do that, right? So he used his position to turn off some of those controls enough so that he can do them. He can do those small transactions. So basically, $300 a pop into thousands of accounts that he was able to create in Canada and overseas. I'm trying to find the story because it's amazing. I like we say all of this stuff in theory, but this guy actually did it. This guy proves what you just mentioned, right?
Well,
So
this is why
I'll
we should
find it
apply least privilege.
exactly. I mean, no, they did,
Always.
but then he used his influence to turn off the controls to prevent him from doing that, right? So if next time, like I
Wow.
want to find this story and post it, because next time
Okay.
somebody says that, okay, here's a story. Here's an actual story
Yeah.
that happened, and it's a piece of art. This guy is a like I learned from him.
An
Um,
evil artist.
Hmm.
an evil artist. Yeah.
On the same topic, should we give network system administrators and help desk people special privileges? And if so, what types of special privileges should they have? So we're saying we don't think executives should have special privileges on the network and other systems generally. But what about a sysadmin? Or what about a help desk person? Do we think they might need extras to do their job?
Depending on their job, but then this is where we need auditing trail. So we understand that the sysadmin cannot delete. So in this case, if something happens, we go and understand what exactly happened. But if this is what they need to do their job, this is what they need to do their job.
Yeah.
Yeah,
Yeah.
I mean, that's definitely what it comes down to, is that it depends on what they have to be doing. Now, it's interesting the difference between, say, someone who's a network administrator versus someone who might be like IT help desk? Should the IT help desk be able to access like staging servers that go into production, or should the network administrators have access to all of the kind of underlying system, like operating system tools that may or may not be available on the endpoints, right? Uh,
Mm-hmm.
Generally, you know, in those cases that uh, system administrators are not going to be actually working on other people's laptops, so they don't really have to have access to certain tools. Like they don't need to have access to, say, the domain administration for
Hmm.
all of the endpoints.
Yes. So a sysadmin and a help desk person, they both need special privileges, but different ones, not the same ones,
Hmm.
Hmm.
to do their jobs.
And as organizations begin to scale out, that becomes more and more and more difficult to manage, and it becomes pertinent to begin to define what all those mean, starting with like domains, right? You have like, so you'd have certain domains of privileges, and those domains get more and more and more specific as they go down to the different things they can do, and then those could be wrapped up in permissions that could be assigned to people, like if you're using Active Directory.
Okay. We have one question left. And then I will ask you both briefly for any specific takeaways you want to emphasize for the
Hmm.
audience. And then, and then I guess we'll say goodbye until next month. Okay, so this is the hardest question because it's the longest answer. Dun, dun, dun.
Hmm.
So this is question 11. This is the last question for chapter 4 for secure code. So your boss tells you that turning on logging and monitoring will cost too much. How do you explain its value and importance from a security perspective? Write a paragraph so we're not going to write a paragraph, we're going to talk about it to explain to your boss, but you need to remember, just a second, just a second, I'm adding another thing there. So wait. So if you speak over your boss's head, you won't pass this question, right? And you're not going to convince your boss. Because I have done this where I'm like, well, the sky is falling. And my boss was like, go away, Tanya, go back to your security corner. So we have to get the message across and not condescend. So like, how would we try to explain to someone like why logging and monitoring is actually important and like the value from a security perspective? I can do this because I'll talk.
Go ahead.
Yeah, go ahead.
Cool. Okay, so I would start off with saying to my boss, okay, dear boss, I have an ask, right? And my ask is to turn on logging and monitoring. I know you feel it's expensive, but let's talk some numbers. So in January, we had a security incident that had to do with credit card numbers. We were passing from one app to another app. So our API takes it from this app that we don't control to this other app and sends it to our credit card handler. But it turns out that some of our credit card numbers got lost somewhere and we don't know if it was us, if it was them, or if it was them. And so we were responding to this incident for 3 straight weeks. And we had 4 people working on it, 2 of them full-time, 2 of them part-time. And then we interrupted a zillion devs to talk about this. It took a total of 400 work hours at a rate of whatever. And then it cost us this much to do this. This is one security incident because we had no logs and we had no monitoring. So we didn't even know these things went missing.
Hmm.
So we're looking at the logs. There's none. There's nothing to look at. So all we could do was try to look at code and try to figure out what might have happened and ask around. And we ended up embarrassing ourselves in front of, I don't know, let's say Visa or MasterCard or American Express. And, they were upset with us and it took, this amount of time for us to solve it and it cost this much. But if we look at the cost of logging and monitoring for a year, it's similar to that price. And I know it's not cheap, but when we add it all up, I'm seeing a return on investment because then we can follow up on these things. We can look into security incidents. And so I want to ask you if instead of us taking the risk and gambling, we do the upfront cost, which we know we have to pay, but we hopefully can prevent or respond much quicker to these things, and also like keep the faith of our customers and our vendors. Sincerely, the AppSec team. This is my thought. Do I have any valid points here?
Yeah, that's it's all. This is excellent. What I would respond with is logging and monitoring is one of OWASP's top 10. Not logging and monitoring would make us uncompliant, and we're contractually under agreement with company A, company B, company C to be compliant with OWASP top 10. AppSec team.
Yes, and PCI compliance. If we want to keep we would be non-compliant for PCI, and if we lose the ability to handle credit cards, where will we be?
Yeah.
Paying 2.7% to Stripe. I mean, like, that's what my company does. But
yeah, me too.
Adding that to your bottom line if you weren't planning for it is a lot.
Yeah. So.
Yeah. We have a comment in the chat, logging and monitoring maybe actually detects a bug in production. That's a really good point. And how expensive really is it, Ben asks. So, Aaron?
Yeah, I go back to what I said previously, is that what these computer systems and the applications that run on them, what they should be doing and what they're actually doing is two different things. And the only way to know what they're actually doing is by logging, right? And then again, logging is only the first thing. We tend to kind of lump logging and monitoring. We almost say it like it's one word, but it is two different things, right? So how we log, what we're logging, how secure are those logs is one thing, but then what do you do with them once you have them, right? So who is looking at them? Do they go to a certain system? Usually a SIEM, which is a security incident and something. I forget the full thing.
Security Information and Event Management System.
Yes. So Splunk is an example of that, right? It's just takes these logs and aggregates them in a way that is so that it can be searched and mostly alerted on. They can create dashboards to see what's going on. And again, it's weird to think, because when it comes to that logging and monitoring, I kind of take for granted that it's just kind of always happening, right? Every organization I go into, they already have this usually set up in place. But it makes me think of like, what would the world look like if we didn't have those things? So what if like the New York Stock Exchange was not tracking the price changes? What would happen? Like if we had a sudden dip in overall stock prices and no one knew, then you're just supposed to be like, okay, cool. Yeah, and you can't investigate why or when, and when is a big point, because if you don't know when these events occur and in what order, you can't actually do any forensics of what happened.
Yeah. Oh, wow. Such a good point. Such a good point. I feel like we all agree on everything and we're awesome. And I want to thank both of you. I want to thank both of you for coming on, and I want us to emphasize some whatever takeaway that we think is the most important. And we covered a bunch of things here. We covered like programming frameworks. We covered logging, monitoring. We covered, bounds checking, input validation. Like there's so many things. But if there was a favorite part, and also like just let me know anything that you want to promote and share with our audience. Do you want to go first, Sharif?
Yeah, for sure. No, I like everything that we discussed, especially the conversation around the safest language, the most secure framework, etc. So that's a lot of a myth in the industry, is that there is a silver bullet. Just use the silver bullet and get rid of security. Security is a day-to-day job. Doesn't start and end. As long as you're writing software, you need to be doing something related to security, just like your health. You cannot say, okay, I'm going to exercise today and that's all what I'm going to use, or I'm just going to use this car and all of a sudden I'm going to become healthy. Yeah, so that's what I liked. My favorite part for today. I'll be speaking to OWASP Victoria in July, so in a month. about static code analysis and bringing order to the mayhem of static code analysis and all of the false positives and the bad reputation that static code analysis has. I believe it's July 31st, 21st, if I'm not mistaken. July 21st at 6 p.m. PST. So looking forward to see you guys there.
Awesome. That's my OWASP chapter.
I know.
That's the one I belong to.
No.
Oh, that's amazing. Aaron, what about you?
I'd say for a takeaway, I think one thing I've come to realize as I've done this work more and more is that doing secure coding actually kind of boils down to some of the basics.
Mm-hmm.
And I find that code that is maintainable, code that is cleanly written, and also code that is well documented is secure code, right? So secure coding isn't just in a vacuum. We can't just say code is like this code is secure. Like going back to those developer basics of like making good applications, it may not seem like I'm actively making it more secure, but by making it something that is, again, clean, maintainable, and well documented is secure code. And those basics really matter, like more than ever even.
Yeah, I would add to that, you can't have high quality code unless it's secure, and you can't have secure code unless it's high quality.
Yeah, it definitely goes hand in hand. Yeah. So, I mean, by myself, again, me and Ray run a blog, hella-secure.com. I haven't contributed, unfortunately, in a while, but, you know, it's one of those things I need to be in the mood to write. Otherwise, it won't be good. I will say that I will be physically located at DEF CON this year in Las Vegas. So if you ever want to meet up or get a drink or something, then I'm going to be there. And again, I believe that's the dates for this year are August 5th to the 8th. And you do have to get your pass online. They're not doing the physical cash thing this year for obvious reasons. Which also means that if you want to do that and you're not vaccinated, please go get your vaccines so you can be safe.
And you can keep everyone else safe.
And you keep everyone else safe. Yeah. Otherwise, maybe I'll see you there.
Cool. Okay, so I have 3 key takeaways, 2 of which are actually just self-promotion. So the main takeaway for real, use the security features built into your framework. Don't write your own. Please don't write your own. If there's an awesome, like if there's authentication, authorization, even like output encoding or input validation, if it's offered, all of the security, like don't write your own identity management, like use pre-existing, well-tested, tried and true systems. Don't write your own. And someone is adding a +1 there. Thank you, Kellen. I also want to tell you that, so I've created a secure coding course. No surprises here. And so if you want to sign up, and there might be a discount. If you want to sign up for the advance notice, I think it's coming out in about like a week or 2 weeks, like really, really soon. Go to newsletter.wehackpurple.com and then /secure-coding-course. And you will get advance notice of the course before the public, and you will get a discount. But again, tell everyone. Yeah, tell everyone. And then the last thing is the next session of this, chapter 5, which is testing and deployment. And it's not pen testing. It's all types of testing to ensure your app is rugged, that it does everything that it can to delight your customers, and it's secure. This is going to be July 10th, same time, same place. Chapter 5, Common Pitfalls. Thank you so much to my amazing, amazing guests. I really, really appreciate you coming and sharing your perspective and all your brilliant thoughts. And I want to thank all of you who have attended or who are listening to this later. Thank you for your comments. Thank you for your questions. Thank you for telling me that you're finding value in these sessions. I honestly just really enjoy the chance to nerd out with cool friends, but I'm so happy to hear people are finding value in our efforts. So thank you again, and we will see you next month for Common Pitfalls, Chapter 5, which is not testing. That's Chapter 6. Okay, bye!